Welcome, Math Models, to sample spaces and the fundamental counting principle. You should have your notes handout, which has the notes for 3 of the videos and for your small group section. And let's get into this. So a sample space in probability is something that tells you all the different possibilities there are for a certain random event. So let's jump into a couple of examples. You've probably learned this before. Maybe the last time was in geometry, I would think. What is the sample space for the outcome of flipping 2 quarters? Well, on my first quarter, there it is, I could get heads or I could get tails. And on my second quarter, I could get heads or I could get tails. So my sample space is heads on both, heads on the first and tails on the second, tails on the first and heads on the second, or tails on both. So that is 4 outcomes. And a lot of people think that these are really the same outcome because they're both quarters, and so how can you tell the difference? But if you'd actually tried it out, actually take 2 coins and flip them a bunch of times, then you'll see that one of each is about double the probability of either both heads or both tails. Or you could pretend you had a quarter and a penny, for instance, and then you would obviously be able to tell the difference. So those would be 2 different outcomes. Second example, you order cheap school supplies from Wish, which if you've not seen that website, it's pretty awesome. Not sponsored, okay? But it's kind of cheapo stuff that comes straight from China, I believe. So when you order something from there, it's cheap, but it takes forever to get to you. Like, you might see it in a couple of weeks from now. So it's definitely no Amazon Prime, but hey, cheap, right? So a lot of the things come in random colors and patterns, and sometimes you don't get to pick what you're getting. It's kind of random. So in this case, you have pens that could be pink, blue, or yellow. You have a pencil bag that could have owls, cats, or unicorns on it. And you have a computer mouse that could have Pikachu or Deadpool. What are the possible groupings of items you could get if you ordered 1 pen, 1 bag, and 1 mouse? Okay, so this looks like it's going to be a pretty big list. I could get a pink pen, then an owl bag, and then a Pikachu mouse. Or I could get a pink pen, an owl bag, or a Deadpool mouse. Or I could get a pink pen, a cat bag, and a Pikachu mouse. Or I could get a pink pen, a cat bag, or a Deadpool mouse. And I'm still not done with the pink pens, because I could get pink and unicorn, and then I could get blue and owl and blue and blah 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 blah. It's going to take a while. So as you can see, this list is going to get pretty long and complicated to keep track of. So one thing you can do is create a probability tree just to help you keep track of everything in an organized way. You've more than likely seen them a lot before when you were younger, and they look like this. You're going to take your, let's say we'll start with our pens, and you're going to list all the possibilities for the pen. And leave a lot of space between them because we're going to make branches below that. So I could have a pink pen, I could have a blue pen, or I could have a yellow pen. And then after I get my pen, I could have 3 options for the pencil bag. So I'm going to basically give each of these 3 branches. And each branch would be owl, cat, and unicorn. So owl, cat, unicorn. And I'm not going to keep writing the entire words. I'm just going to put owl, cat, unicorn. Owl, cat, unicorn. So that kind of represents I get a pink pen, an owl bag, and then we'll get to the computer mouse in a minute. Or I could get a blue pen, a cat bag, and then again we'll get to the mouse in just a second. Then, okay, so I've got my pen possibilities, I've got my pencil bag possibilities. Now I have my computer mouse possibilities. And no matter what pen or bag I get, I have 2 choices for mouse. So I could get the Pikachu mouse or the Deadpool mouse. Or I could get pink pen, cat bag, Pikachu mouse. Or I could get pink pen, cat bag, Deadpool mouse. Or I could get pink pen, unicorn bag, Pikachu mouse. Pink pen, unicorn bag, Deadpool mouse, and so on. I'm going to do the same thing on these. So there's all my possibilities laid out. So again, you have your pen possibility. For each of those, you have 3 possible bag patterns. And for each of those, you have 2 possible computer mice. So one order would be like pink cat Pikachu or yellow owl Deadpool, something like that. You're going to go down the whole tree. So to figure out how many possibilities you have, you're really just counting the ending branches. So 1, 2, 3, 4, 5, 6. There's 6 there. There's 6 more here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I have 6, 12, 18 total possibilities. There's 18 possible ways that my order could show up with those different choices in them. Yep. Okay. You've probably seen this before too. The fundamental counting principle is just a shortcut to do this. It will only show you how many possibilities there are. It's not going to help you list them or organize them in any way. But if all you need to do is figure out, hey, how many ways could this order show up on my front porch, then that's plenty. That's more than you need. So you basically list how many choices you have for each item. So I have pen choices. I have, pencil bag choices. I have computer mouse choices. And you say how many choices you have. So there's 3 pens, 3 pencil bags, 2 computer mice, and you multiply them together. And that's basically what the tree is doing. You have 3 pen choices. Notice we have 3 of the identical trees. 3 pencil bags for each one. 1, 2, 3, 1, 2, 3. So that's the 3 times 3 right there. If you ignore the computer mice, ignore that, there's your 3 times 3, which is 9 so far. And then for each of those choices, you have 2 computer mice. There's your times 2. So 3 times 3 times 2 is 18 possibilities total. So basically, there's your sample space. This is the sample space. This is how many items are in the sample space using the fundamental counting principle. And then we're going to do one more example of this. You could write out the whole tree. We're not going to do that. We're just going to figure out how many possible drinks you could make. So a fast food place has 3 sizes of drink with 10 different base sodas and 6 different add-in syrups. Kind of like Sonic, but not as awesome, because they don't have as many choices. Pretty sure Sonic has a lot more. Anyway, so just like here when we did pen choices, pencil bag, and computer mouse, we're going to do sizes of drink, the base sodas, and then the different syrups. So sizes, sodas, syrups. Multiply them together. 3 sizes, 10 different sodas, 6 different syrups, and that is 180 different drinks that you could make. And just from those few choices. So that's pretty much all there is to sample spaces and fundamental counting principle, at least as far as we cover it in Math Models. Thank you for watching.